Good morning, one and all present. Myself, HEMALATHA. Now I'm going to present my PPT based on laser for measurement of current and voltage. Here we can see how the laser principle is used for measuring the current and voltage, and also we can see the construction and working of it. First, the principle. The principle is if a polarized light is passed along a magnetic field of strength H and plane of polarizations is rotated by an amount given by phi is equal to integral of h dl, and phi is equal to Vni, where phi is equal to angle of rotation and V is equal to Verdet constant for the medium, and h equal to magnetic field strength, L is equal to path length, and I is equal to coil current. Here Verdet constant is nothing but it is an optical property. It describes the strength of Faraday's effect. This is a diagram of measuring the measurement of voltage and current lasers. Here the laser which sends the laser light into the high verdant constant glass with the filter in between it. It is a polarizing filter. Polarizing filter is nothing but the vibration occurs in the reflections of the laser light produces. It is a single plane light. Next, when it enters into the filter, it gets filtered and it moves into the high verdant constant glass, and then the laser is then moving towards the polarizing filter, and it also get filters and it moves into the detectors. It's working a system. This is a system used for current and voltage measurement. It is based on the Faraday's law. Faraday's law is nothing but a voltage, a rotation of plane of polarizations which nearly proportional to the magnetic field directions of propagations. It occurs only in the optically transparent dielectric material under the influence of magnetic field. The light which gets from the lasers is passed through the polarizing filter and then through a high verdant constant. Verdant constant, we already know that it is an optical property which describes the strength of the Faraday's law. And Verdant constant glass rod and a magnetic field of the current to be measured. Here the magnetic field is to be measured. The transmitted light passes through a second polarizing screen aligned in a 45-degree angle to the first screen and then to the detector. With no current flowing, a steady signal will be received at the detectors. In the presence of current, the plane of polarization will be rotated clockwise or in an anti-clockwise depending upon the directions of the current, while the angle of rotation will be functions of the current or voltage measurement. If the current is there, it will be rotated in a clockwise or anti-clockwise. If it is not there, there is no rotation in it. Thank you all.